This will be for the Kuta software worksheet, segment lengths in circles. Okay, in the first section, they want us to solve for x and assume that lines which appear tangent are tangent. So we'll be going over three theorems. Okay, the first one is the segments of chords theorem. If two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So here we have two chords intersecting inside a circle. They intersect at point E, and the equation is EA times EB, which is going to be this times that, and that equals EC times ED, which is this times that. So you just multiply the two segments of one chord, set it equal to the product of the two segments of the other chord. All right, let's look at number 5. So we have two chords intersecting inside a circle. We just multiply the product of the two segments for each chord and set them equal to each other. So we have this times this. So it's going to be 4x plus 2 times 8. And use parentheses. And that's going to equal, I'll do it in a different color. Actually, I'll use the same color. I'll do this times that. So that's going to be 9 times 4x. All right, see if you can solve that one, please. Solve for x. All right, distributing the 8. We have 8 times 2, that's 16. And we have 8 times 4x, that's positive 32x. And 9 times 4x is 36x. All right, we want variables on one side and numbers on the other. So since I have a 16 here, I want to get rid of this. The opposite of positive 32x is negative 32x. The 32's cancel. Bring down the 16. Bring down the equal sign. 36 minus 32 is 4. And we still have x. This is x times 4. The opposite is divided by 4. And 16 divided by 4 is 4. And that equals x. The 4's cancel. So that's all they asked for, just x. Now on the second page, they want us to find the measure of the line segment indicated. Okay, please pause and try number 14 and see if you can solve for x at least. And if you do, then they want you to find CA, that's this whole thing right here. So you'll have to plug in for x and add 14. All right, so multiplying the two segments of each chord, we have this times this. So that's 3 plus 3x times 14. Use parentheses. And set it equal to this times this. So 12 times 4x plus 1. Again, use parentheses. Okay, distributing. 14 times 3, that's going to be 42, and we still have x. And 14 times 3 without the x is just 42. 12 times 4x is 48x. And 12 times positive 1 is positive 12. All right, variables on one side, numbers on the other. I'm going to get rid of positive 42x by doing the opposite, negative 42x, to both sides. Cancels here. Since x's are here, I want to get numbers on the left. Opposite of positive 12 is negative 12. Cancels here. 42 minus 12 is 30. 48 minus 42 is 6, and we still have x. Okay, the opposite of times 6 is divided by 6, and 30 over 6 is just 5. Now, that's not what they asked us. They asked us to find CA, so we need to take that 5 and plug it in. All right, so what I'm going to do, since we're looking for CA, which is this whole thing right here, I want to take x equals 5 and put it in right there. Okay, so CA is going to equal this whole thing added together. So 3 plus 3x is going to be 3 plus 3 times 5. And we also have to add this piece, which is 14. Okay, 3 times 5 is 15. 3 plus 15 is 18. Plus 14 is going to be 32. So that is your final answer. Okay, you can do number 16 on your own, but I'll give you a hint. When you multiply these two segments here, you're going to get x squared, and you're going to have to take the square root of both sides at the end to solve for x squared. Then, of course, you plug it in to find WS right here. Okay, for the next theorem coming up, you want to know that this line here in blue is the tangent segment, and that's because it intersects the circle at just one point. And this line here, the red and the black combined, that whole thing is called the secant segment, and that's because it intersects the circle at 2 points. So this whole thing is the secant segment. And the red part that is outside the circle is just called the external segment. So we're going to use these terms in the next theorem. Segment of secant's theorem: if two secant segments share the same endpoint outside a circle, the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. All right, so this theorem is when you have two secants and they meet outside the circle. Okay, they each intersect the circle twice. That's why they're secants. We have EA times EB. That's this piece times the whole thing, and that equals EC times ED. This piece times the whole thing. So you multiply the external segment times the whole thing equals external segment times the whole thing. So here we have two secant segments. Notice each segment intersects the circle at 2 points. So these are both secant segments. All right. So we have the external segment, which is 4, times the entire segment, which is going to be 4 plus x minus 3. And that equals the same thing on the other one. The external segment, which is 5, times the whole thing, which is 5 plus x minus 6. All right, so I would combine like terms first. We have the 4, and 4 minus 3 is 1. And we still have positive x. On the right, combining like terms, keep the 5. Inside parentheses, we have 5 minus 6, that's negative 1. And we still have positive x. All right, and now distribute. 4 times 1 is 4. 4 times x is 4x. 5 times negative 1 is negative 5. 5 times x is 5x. Okay, x is on one side, number is on the other. I try to keep the x's positive by subtracting the smallest one, but you don't have to. Anyhow, opposite of positive 4x is negative 4x. And this one cancels. X's are here. I want numbers on the left. Opposite of negative 5 is positive 5. Do it to both sides. 5 minus 5 is gone. 5x minus 4x is 1x, or just x, and 4 plus 5 is just 9. Okay, in this section, they just said to solve for x, so we don't have to plug it in. All right, please pause and try number 12, and I'll give you a hint. If you can solve for x, they want you to find NL, so that's this whole segment right here. So you're going to have to plug in for x and add x minus 8 plus 4 at the very end in order to solve for NL. All right, so let's set up the equations. We have the external segment, which is 4, times the whole thing, this whole segment here, which is going to be 4 plus x minus 8. And now we do the same thing to the other segment. You take the external part, that's 3, and use parentheses, that's times this whole thing. So it's going to be 3 plus x minus 5. All right, 3 plus x minus 5. All right, combine like terms inside parentheses. Keep the 4. Inside parentheses, 4 minus 8 is negative 4. And we still have positive x. And that equals 3. Inside parentheses, 3 minus 5 is negative 2. And we still have positive x. Okay, distributing. 4 times negative 4 is negative 16. 4 times positive x is positive 4x. 3 times negative 2 is negative 6. And 3 times x is 3x. All right, you want numbers on one side, variables on the other. I always subtract this. I try to subtract the smaller x, so 3x is smaller. I'm going to do minus 3x on both sides. And it cancels here. X's are here. I want the 16 on the other side. Opposite of negative 16 is positive 16. Do that to both sides, and it cancels here. 4x minus 3x is x. Negative 6 plus 16 is 10. Now, that's not what they asked us. They asked us to find NL. So we have to take that 10 and plug it in. All right, so we're looking for NL. So NL, going from N to L, is this entire segment right here. All right, so x equals 10 is going to go right in there. So for NL, we're going to have this piece, which is 10 minus 8. You can use parentheses, but you don't have to. And then we're going to add this piece here, which is just 4. So pretty simple. 10 minus 8 is negative 2, plus 4 is positive 2. Nope, that's a mistake. Don't know why I said that. 10 minus 8 is positive 2, plus 4 is 6. Okay, last theorem, segment of secant and tangent. If a secant segment and a tangent segment share an endpoint outside the circle, then the product of the lengths of the secant segment and its external segment equals the square of the length of the tangent segment. So this is for when you have a tangent and a secant, and they meet outside the circle. This one right here is the tangent, because it just hits the circle once. This one here is the secant, because it hits the circle twice. All right, and they're saying EA squared, so that's this times itself, and that equals EC times ED. The external segment times the entire segment. All right, let's look at number 7. we have a tangent and a secant. So we're going to do the tangent times itself. So that's 6 times 6, or 6 squared. And that equals the external segment, which is x, times the whole segment, which is x plus 5. Six times 6 is 36. And that equals distributing x times x is x squared. And x times positive 5 is 5x. All right, we have a quadratic, so you need to set it equal to 0. All right, so we want to get rid of the 36. I'm going to do minus 36 on both sides. And it cancels here. And I'll rewrite it, x squared plus 5x. You don't have to rewrite it, but I want to make it so you guys can see it. Minus 36 equals 0. Okay, now we need to factor this. So we need two numbers that multiply to negative 36 and add to positive 5. All right, so I'm going to write out the factors of negative 36. So you can do negative 12 times 3. That doesn't add to 5. You can do 12 times negative 3. You can do 4 times negative 9. That adds to negative 5. Or you can do negative 4 times positive 9. These two add to positive 5. So we're going to use those two numbers right there. So you want to make two binomials, two sets of parentheses with two terms each, and that equals 0. All right. So the only way to get x squared is to have x times x for the first terms, and then we're going to use negative 4 and positive 9. Negative 4 and positive 9 inside parentheses. All right. If you want to double check, you can distribute or use FOIL, but just looking at the inner outer, negative 4x plus 9x is going to be 5x. Anyhow, anything times 0 equals 0. So these are multiplied by each other. So this can equal 0 or that can equal 0. All right, so doing them separately, x minus 4 equals 0 and x plus 9 equals 0. Okay, solving for x, if we do, you can do this in your head really, but if you do plus 4 on both sides, the 4's cancel and x equals 4. If you do minus 9 on both sides, the 9's cancel and x equals negative 9. Now, are both answers correct? Well, let's check the diagram. Okay, if you see on the diagram, x is this side length right here. Okay, a side length, or a segment length, I should say, cannot be negative. So x equals negative 9 is impossible, and x equals 4 is the only answer. Okay, please pause and try number 11. And I'll give you a hint for this here. You're going to get x plus 3 squared. You're going to have to distribute and solve for x. Once you do that, they want you to find nm, so you're going to have to plug in for x right here. All right, so let's see. We have the tangent segment, so you multiply it times itself. So it's x plus 3 times x plus 3. All right, you can write x plus 3 squared if you want to. But you can write x plus 3 squared, but we're going to have to distribute that or use FOIL. So you might as well write x plus 3 times x plus 3. And on the other side, that equals the external, which is x minus 3. Use parentheses. And then times this whole thing. So it's going to be x minus 3 plus 16. All right, I'm going to need more room. So it's times x minus 3 plus 16. All right, distributing on the left, you can use FOIL or distribute. I'll just distribute. X times x is x squared. X times 3 is positive 3x. 3 times x is 3x. 3 times 3 is positive 9. And we still have the equal sign. All right, we might as well simplify this before distributing. So negative 3 plus 16 is going to give us x plus 13. So all I did was combine these two right here and left the x. All right, so now distributing on the right-hand side, x times x is x squared, and x times 13 is 13x. Negative 3 times x is negative 3x, and negative 3 times 13 is negative 39. Now, I'm noticing, as far as square numbers are concerned, I have an x squared on both sides. I can easily get rid of that by doing the opposite. Just do minus x squared on both sides. Okay, so the x squareds cancel on both sides, and we can combine like terms. 3x plus 3x is 6x, and we still have positive 9. Bring down the equal sign. Combine like terms, 13x minus 3x is 10x, and we still have negative 39. Solving for x, I usually subtract the smaller x, so I'll do minus 6x on both sides. Cancels here. The x's are here. I'll do the opposite of negative 39, and that's positive 39. On both sides. 39 plus 9 is 48. Bring down the equals. 39 minus 39 cancels, and 10x minus 6x is 4x. Solving for x, the opposite of times 4 is divided by 4. Okay, and 48 over 4 equals 12. Now, that's not what they asked us, so we have to take this, x equals 12, and plug it in. All right, they asked us for nm, so nm is this right here. We take the 12, x equals 12, and plug it in right there. So mn is just 12 plus 3. And of course, 12 plus 3 is just 15. So I wrote mn and they said nm, but that's the same thing.